Okay, so I'm going to get started with this demo here. I'm going to try to clarify a lot of the things that we talked about in the lecture. And you'll see that I'm going to use a lot of the terms discussed, the different datums, the different coordinate systems, potentially the different projections. So you can see that I'm an arc map here. I've got an MXD open that's called Projections Coords. This is just a demo that I use both in class and on the web. You'll notice that I have three different data frames, NAD83M, indicating that this data, which I've actually named this shapefile, Maryland counties, NAD83M. So that's just a tip off to me in the file name that this particular shapefile of counties in Maryland is in North American datum 1983 and measured in meters. And I can double check that by looking at the properties and looking at the source. And I can see that it is NAD 1983, State Plane, Maryland, FIPS 1900. You can see the projection that it's using. Remember I said in the lecture that State Plane coordinate systems to optimize for local accuracy use conic projection. So you can see the Lambert conformal conic projection being used here. So what I've done is I've done the same thing for each of these other data frames. You'll see that the color of Maryland changes when I change data frames. And again, I've just named the data frame and the shapefile that's in there accordingly. So I'm going to open up each one of these. And again, you can see North American datum 1927, State Plane, Maryland. So State Plane coordinates is the coordinate system that we're using. I'm going to activate longitude and latitude. And you'll notice that Maryland kind of gets flat and sort of stretched out. We're using decimal degrees in this case. And you can see the coordinates down here in the lower right-hand corner. As I mouse around, basically what I'm doing is I'm moving further west, and that's why the negative gets higher and higher as I'm moving further west from the prime meridian. And then you can see the decimal degrees get higher and higher as I move higher in latitude as well. So here in Maryland, we sit kind of between 37 and 39 degrees north latitude, north of the equator, and about anywhere from 75 to 79 degrees west longitude. So west, of course, in that coordinate system being in the negative direction. So what I'm going to do is I'm just going to activate my NAD83M data frame, come back here to Maryland, and I've made them different colors so we can understand which data frame we're looking at. So you can see over here in Arc Catalog, and I've just opened up Arc Catalog within ArcMap. When you use this Arc Catalog or Catalog window button, it just opens up Arc Catalog temporarily within your ArcMap session, and you do have a lot of the functionality that you have in the full-blown Arc Catalog, but you can launch Arc Catalog as its own separate module as well, so you can do your data management. Remember that Arc Catalog is your data management component of ArcGIS. So you'll see that I have several versions of the same shapefile. I've got Maryland Counties lat long, which corresponds to this Maryland Counties lat long. Maryland Counties NAD27F, so North American datum 1927, measuring in feet, so that corresponds to this shapefile, NAD83M and NAD83M. You'll also notice that I have a couple of shapefiles that are unknowns. I just named them as being unknown because I don't know what the coordinate systems are, and we'll kind of try to solve a problem here. You also see that I have Maryland highways lat long, Maryland highways NAD83M, and Maryland highways unknown. And the reason they're unknown for these different unknowns is that I don't know what the coordinate systems are defined as. So if I look at the XY coordinate system information, it's unknown, and I could actually go in and select it and tell it what type of coordinate system it is. In this case, I don't really know if these unknowns are a geographic coordinate system where I use a longitude-latitude based projection file like WGS 1984. There's our World Geodetic System of 1984 example, which is going to use longitude and latitude coordinates. Or if it's a projected coordinate system, which could be any number of these different systems, I'm going to gravitate towards the state plane systems because using Maryland data, using local state data, the likelihood of an unknown file being state plane is actually pretty good, or UTM is one of the possibilities. So we're going to kind of solve this and sort of figure it out. So I use highways and I use counties to kind of set up a context for my demo. Let's say we've been asked to create a transportation map, and I know I have counties for Maryland. I'm making a transportation map of the major highways in the state of Maryland, and someone gives me a shapefile that is in NAD 83 meters for the counties, and then I ask someone else in maybe my transportation department, hey, do you have the roads, the major roads or the Maryland highways, and they give me the Maryland highways NAD 83M shapefile. The expectation is there is that they would line up. So I've gone ahead and added in my highways. Maybe I'll just change the color so we can kind of see that a little bit better. So these are both projected into the Maryland State Plane NAD 83M coordinate system. So if we look at the properties again, we can see that. Now, if I take my Maryland highways lat long and I add it in here, what could be surprising to you, and I'll go ahead and turn off the Maryland Highways NAD 83M, is that the longitude-latitude version of that same file also lays on top of the NAD 83 version of my counties. Now, that might seem odd at first, but what ArcMap is doing there is something that is known as on-the-fly projection, or projection on the fly. So what's happening here is that this shapefile is defined as being in longitude and latitude. Let's look at the properties here really quick. So it is a geographic coordinate system. Remember, longitude and latitude measurements, or the longitude and latitude coordinate system, is a geographic coordinate system, GCS, and it uses the World Geodetic System of 1984 as the spheroid, or the ellipsoid, and that is used for measuring longitude and latitude. We can see that that's defined as that, and so what ArcMap does is says, I know what this file is defined as, I know what this file is defined as, I can project this one onto this already existing NAD 83 meters shapefile. So if I turn that off and I just mouse around here in the Maryland State Plane NAD 83 meters version of this county file, notice the coordinates down here. We're making measurements in meters, and we're measuring in hundreds of thousands of units, in this case hundreds of thousands of meters. Whereas with longitude and latitude, we still see those same units, because this data frame here has accepted the coordinate system of this particular shapefile. If I were to come over here and activate my longitude, latitude, or my geographic coordinate system of Maryland, MD counties lat long, as I mouse around, again, notice the coordinates down here in the lower right hand corner. So what we're looking at is defined coordinate systems, layers with defined coordinate systems that are correctly defined. And a lot of times I use the analogy with my in-person class of driver's licenses and people. So if you were to find someone, say, face down out in the real world, and you're going as a good Samaritan to help them out, and you don't know who that person is, you look at their credentials, or you look at their driver's license, and if you see that the driver's license matches the picture, you're pretty confident that that person and that driver's license are a match. For example, if you find Professor Alvarez laying in a ditch, and you pull my wallet and you see that I have John Travolta's ID in my pocket, that's a bit of a problem there. So that's kind of the same problem that you're going to run into if your shapefile in longitude and latitude is actually in longitude and latitude, but it is defined as being in Maryland State Plane NAD 83 feet, NAD 83 meters, NAD 27 feet. You have to make sure that your data, whatever coordinate system it's in, is properly defined, properly identified. So if we look at Maryland highways, for example, we can see that it is improperly or not improperly defined. It's not defined, so we don't really know what coordinate system that is in. So if I take these off, I'm going to just clean this up, and please bear with me with the silly analogies, but if I were to take the Maryland Counties Unknown shapefile, and I'm going to activate the NAD 83 meters data frame, and I'm going to add in the shapefile here, you can see that the Maryland Highways Unknown shapefile does not line up with Maryland. So my transportation map is not off to the greatest start. A lot of times what you can do to solve this problem is to check your data against other data layers that are known, that exist in the proper coordinate system. So for example, again, Maryland Highways Unknown, I don't know what that coordinate system is. Now if I remove this layer and I say, you know what, I think I know that this is in longitude and latitude. So I'm going to say WGS 1984. That's the spheroid that we use, the more recent one for longitude and latitude. And I say OK. So now my unknown has a description for its coordinate system to be in WGS 1984. I'm going to take that and I'm going to add that in. And I'm getting a warning here that I have an inconsistent extent. So when I zoom to the layers, I'm not even getting that layer showing up. So I'm going to remove that, and I'm thinking, you know what? That's probably not in the right coordinate system, and I did not define it. I'm going to throw it in here, and I'm getting the same problem. So I'm going to go ahead and remove that, and I'm running into the problem that I just don't know what coordinate system this unknown is in. If I copy it, or if I just drag it into my NAD27, and I activate that NAD27, I'm finding that I can't see that data anywhere. So I've got a real problem there. So I'm going to remove that. I'm going to say, well, you know what? I just defined that unknown as being in WGS 1984, and something tells me that just is not right. So I'm going to go ahead and try the projected coordinate systems. I've got a couple of other ones, and I said that NAD83 and NAD27 are common ones used in North America, but it's very clear to me that longitude and latitude is not the coordinates for that unknown file. So I'm going to come in here and I'm going to say, you know what, I'm going to test this, and maybe it's in NAD27 feet. So I'm going to slide over to Maryland, NAD27 feet. I'm going to add that, and I'm going to tell that layer that it is now in NAD27 feet. So if I take that and drag it in here, that actually does show up. So it's able to take that unknown, and because it knows what it's in, it can project it to show it on top of NAD27 feet. And since it is properly defined, again, as being in NAD27 feet, I can actually take that and copy that layer into another data frame and activate that data frame. And you can see that it lays on top of it as well. So even though I've called it unknown, it's unknown over here, I've just discovered that it's actually in NAD27 feet. And I've defined it as being in NAD27 feet. So now ArcGIS knows what to do to handle that file. I'm going to go ahead and remove this for just a second. And I'm going to come down here to longitude and latitude. And I'm going to take that unknown and add it in there as well. And you can see it's basically projecting this Maryland Highways unknown shapefile, which is now known. We've defined it as being in NAD27 feet, and it's projecting it to longitude and latitude. So those layers now line up. I can do the same thing here. I'm going to remove my longitude and latitude, and I'm going to add in a Maryland county's unknown into this data frame, and I can see that those two do not line up. I can't see the highways anywhere. When I zoom to the highways, I'm just going to right click and say zoom to layer. It takes me to the highways, which is projecting, remember this unknown is in NAD27 feet. It's projecting it into longitude and latitude. When I zoom to layer on this Maryland counties and I measure around, look at the coordinates down here in the hundreds of thousands and millions. But it's in decimal degrees. So if you can imagine these coordinates in decimal degrees, this file is way, way, way out of line compared to this one. In fact, this one is in coordinates that we can't even see down here near the 0, 0 line. We can't even perceive the data because it's so small down here in the corner. We actually have to zoom to it. So what I can do here is I can say, well, Maryland County's unknown. I have a theory that you both might be in NAD27 feet. Again, there's my undefined. And what I'm going to do here is I'm going to remove this, and I'm going to define it over here in our catalog where I manage my data. And I'm going to tell it state plane NAD27 feet Maryland. So now I've just told that unknown shapefile for counties that it's in NAD27 feet. And I'm going to apply that. So when I drag it back over here, they actually do line up. So I can take them and drag them up here. And I can see that in this data frame, they're all going to line up as well. Now, that's really key to remember that we're talking about defining what coordinate systems each of these layers has. And this is because I know the data. I know this Maryland data. I know these highways. I know that longitude, latitude, the state plane coordinates, UTM, for example, are some of the more common coordinate systems used. However, if I have a layer, I'm going to come back up here to the top. If I have a layer that I know is in nat 83 meters, I'm going to go ahead and confirm that. This is in nat 83 meters. And when I mouse around, I can see I've got coordinates down here, and it's telling me that's in meters. I know this data well. I know that this is in the right coordinate system. If I want this version of this shapefile, which happens to be this one, and I want to project it into another coordinate system, whatever coordinate system that may be, I actually can't just go ahead and say, oh, you know what, you're not in nat 83 meters anymore. I'm just going to select this other coordinate system and tell it that it's in WGS 1984, or come in here and say, oh, now you're in nad 27 feet. You cannot just do that, because all this process is showing you is that you're telling the coordinate system what it's in. What it's actually in may be different. And so that's that silly analogy of you find Professor Alvarez out there face down in a ditch, but he's got John Travolta's driver's license. That's not going to work. Someone may have just switched out our licenses, and it doesn't make sense. If you find me, you look at my license and it says Jamie Alvarez, you see that the picture matches, that's one thing. But if they don't match, it's kind of like your definition for your coordinate system not matching for your GIS layer. Again, a silly analogy, but hopefully everybody knows who John Travolta is. Maybe I'm dating myself there. But if I want to actually change the coordinate system or change this file to another file in a different coordinate system, I would actually use Arc Toolbox, and I would have to go into Data Management. And we'll use the toolbox a little bit more later in the semester when we get into geoprocessing. And I want to project my features. You can project rasters, or you can project vector layers, which we call features or feature classes. So when I say project, it opens up a dialog. I'm just going to drag it over here into my other screen. And it tells me, what do you want to project? So it asks me, what's the input data set? Maybe I want to take the nat 83 meters version, and notice that it picks that up. It automatically knows what it's in, and I want to tell it I'm going to write out a whole new shapefile, and that output shapefile is going to be called, and I'm going to kind of borrow the file name here, and maybe I'm going to call this one UTM, because I want to project this to a UTM coordinate system. And so now it's going to ask you, what do you want to project this new shapefile into from this old coordinate system? And so when I click on that, I'm going to select projected coordinate system, and there's a UTM folder. And then I'm going to use nat 83 as my datum, and it's going to have every one of those 60 zones that we were talking about within nat 83, within this portion of the world. And so let's say we wanted to project it into Maryland Zone 18 UTM. I would say OK. I would say OK. And I basically have set this up to project from nat 83 into a whole new shapefile in UTM Zone 18. So when I run that, it's going to project the data. I'm going to go ahead and close this. You can see that it's doing something down here at the bottom. It's saying project, 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 project. And because this is my active data frame, that's the one it's going to put my new layer into. Now, of course, this automatically projects on the fly. So even though that this is a UTM version of this nat 83 meters shapefile, there are two different shapefiles now. And they're projected correctly and they're defined correctly, they will project one on top of the other. But I can go ahead and insert a new data frame here. And when I copy that shapefile and paste it in here, you can see the shapefile kind of takes a little bit of a rotation there. And you can see that the coordinates are different here. We're in the 300, 200,000s, 300,000s in the Baltimore area. Whereas when we come back here and reactivate our nat 83, I'm just going to go ahead and remove this guy. And when I mouse around here in the Baltimore area, I'm using a completely different coordinate system with different units. And actually the units are the same, meters, nat 83 meters and UTM meters. However, the coordinate systems themselves are different. So we're measuring in different units. So when I come down here to NADITY3, or excuse me, to new data frame 3, I'm back to my UTM version of Maryland counties. Now I did have a Maryland counties unknown 2 up here just as a second demonstration. I can actually take that, I can drag it in here, and it looks like they line up nicely. So now I know that my unknown 2 is in UTM. Since it's unknown, if I drag it up here into my lat long geographic and I activate that, and I zoom to layer, or zoom to the extent, now Maryland is up here. This is my unknown. And then of course down here is my Maryland counties unknown that I do know what that is in. So I look at that and I know that that's in NAD 27 feet. And remember, we defined that earlier in the demonstration, and that's kind of floating out down here somewhere. So if I tell that unknown, let me zoom to the extents again, tell that unknown 2 what it's in, and if I'm not mistaken, it's in zone 18 as well. I apply that. I've just told it what coordinate system it's in, and it actually projects it on the fly into my NAD 27s. And I did use my lat long geographic data frame, which I should have been working in here if I was working in NAD 27 feet. But again, this is more for demonstration, more to kind of expose you to this. Projections and coordinate systems are not easy to get at first, so don't sweat this too much. I realize I went through this demo very quickly. I'm moving things around. I'm in ARC catalog, I'm in ARC map, I've got lots of different coordinate systems that I'm using. And as you move into future assignments, you move into future projects, especially project number 1, project number 2, you may have to consult with me to deal with these kinds of issues. If you get to the point where you've got data for one particular area, maybe your study area is Maryland, or maybe it's a specific country somewhere in the world or another state, and you're getting layers that do not match up, consult with me and I can help look at that data and see what the coordinate system issues are. Again, a demonstration meant to expose you to this and use some of the language that we learned and that we used in the lecture. So now you're moving into practicing this a little bit. Changing the projections of different data frames, not necessarily of the data, but of data frames in Chapter 13, so that you can map different parts of the United States that are in different latitudinal zones: Alaska, the lower 48, and Hawaii. So practice a little bit of this in Chapter 13, and that's going to wrap up this module.